So in this video, we're going to talk about phase shift and the vertical shift, which is we're going to discuss about a sinusoidal functions, the letter C and the letter D. Okay, now let's have a quick review what is a sinusoidal function in a general form. So we have a sine bx minus c plus d. Or if it's cosine, will become cosine bx minus c plus d. They are the same. Now, if we want to see a function shift, we want it to be directly interact with x, which means we want it to be subtracting or adding directly from x, not from bx. So what happens is we need to factor out the b. So we have x minus c over b. So once you factor the b out of x and bx and the c, then we will get this function. So this gives you what? Anyone remember from 114.1? Oops. This gives you a shift to the left or to the right. Since you are subtracting, we assume that c and b are greater than 0. So that means this means a shift to the right if it's a positive number. If it's a negative number, you minus a negative number, it gives you a shift to the left. So, for example, I have a sine x minus 2/3. This is going to be what? To the left, 2/3 units. It's my dog saying hi. Okay. So we're subtracting 2/3. That means you're going to shift to the right 2/3 of the units. What if we got sine x plus 3 over pi. So this is going to be what? To the left, 3 over pi units. Now let's check that on decimals. Sorry, somehow I can't open decimal. But anyway, this means the whole function is going to shift to the right 2/3 and then shift to the left 3 over pi. You can check it at decimal graphing calculator by yourself. Compare that to a sine x function, but you're already familiar with that. You might not need to check that. All right. Next is the vertical shift. After we talked about the horizontal shift. So when it comes to vertical shift, it's related to the letter D. For example, if we have sine x plus 4, that means we're going to be up 4. If we have a cosine x minus pi, that means the midline is going to be down by pi units. So the midlines become y equals to negative pi. On the top, the midline is y equals to 4 because you shift up. Okay, now exercise, for example, fx equals to cosine x plus pi over 2 minus pi over 3. Let's take a look at each letter and see what does that mean in each one. So pi over 2 is what? Is our letter C, since our b is equal to 1, so we don't need to consider c divided by b. And we got that to the left, pi over 2. And then when you minus pi over 3, the whole function will be down pi over 3. Here is a second example. Fx equals to sine 2x plus 4 plus 1. Now, this time we need to consider the b. Since we have a b, we need to factor the b out first. So, simplify, we have a sine 2x plus 2 plus 1. And then what happened to the function? The 2 is the period, right? Oops. The 2 is the period. The period should equal to what? 2 pi divided by 2, which is pi. And then at 2 means to the left 2 units. At 1 means it's going to be up by 1. Okay, now next one, I'm going to add in all a, b, c, d into the sinusoidal general function. I have fx equals to 3 times sine 1/2 x plus 3 plus 1. We know that our a, b, c, d, a is the amplitude, which is equals to 3. That one is the easiest one. In fact, it should be equals to the absolute value of a, which is equal to 3. B gives us the period is related to b. The period is going to equals to 2 pi divided by absolute value of b, which is 2 pi divided by 1/2. That gives you 4 pi. So the period is equal to 4 pi. The next is the phase shift. The phase shift is equals to c divided by b. So the c is equal to 3. B is equal to 1/2. B is not equal to 4 pi. 4 pi is the period. B is equal to 1/2. It's different. We get the period from B, but not necessarily B is the period, because sometimes I made that mistake too. Anyway, the phase shift is 6. This is a positive 6, meaning that this is left 6. The easiest one is the vertical shift, which is our D equals to 1. So that means the midline is equal to 1. Now, if we put everything together, we should have a graph. So I know that this is sine function, so it should look like this way, right? We put in every 2 pi. Oops, this should be drawing a little bit lower, make it nicer. Okay, this should be 4 pi. But now your amplitude is become 3. So originally it was 1. Now it got stretched vertically and become 3. And this is 1, -2, and 3. So that means the biggest point would be in here. And then also the midline is going to shift up 1. So that means the highest point is even going higher. It's not even 3. It should become 4 now. Let me draw that. So here is the midline. Midline is in here. Y equals to 1 is the midline. So that means we shift the whole function. So that means the highest point should become 4 here. And next is the phase. So at beginning, no, the next should be the period. At beginning, the period is every 2 pi, but now is every 4 pi. Not just that. The whole function shift to the left 6 units. So to the left 6, that means the function starts at, let's say here is 6, sorry. And that means -6. So that means our function starts at the midline here. and go all the way up, down, and then add the function at here, pi minus 6. So that's the whole function. You might have a hard time to